live in a universe of patterns. Every night the stars move in circles across the sky. The seasons cycle at yearly intervals. No two snowflakes are ever exactly the same, but they all have six-fold symmetry. Tigers and zebras are covered in patterns of stripes. Leopards and hyenas are covered in patterns of spots. Intricate trains of waves march across the oceans. Very similar trains of sand dunes march across the desert.
Natural order, the orderly system comprising the physical universe and functioning according to natural as distinguished from human or supernatural laws. Ian Nicholas Stewart is a British mathematician and a popular science and science fiction writer.
The six-cornered snowflakes. 400 years ago, the German astronomer Johannes Kepler wrote a small book, The Six-Cornered Snowflake, as a New Year's gift to his sponsor. In it, he argued that snowflakes must be made by packing tiny identical units together. His main evidence was the six-fold symmetry of snowflakes, which is natural consequence of regular packing. If you place a large number of identical coins on a table and try to pack them as closely as possible, then you get the honeycomb arrangement, in which every coin except those at the edges is surrounded by six others, arranged in a perfect hexagon. The regular nightly motion of the stars is also a clue. This time to the fact of the Earth rotates, waves and dunes are clues to the rules that govern the flow of water, sand, and air. The tiger stripes and hyena spots attest mathematical regularities in biological growth and form. Rainbows tells us about their scattering of lights and indirectly confirm that raindrops are spears, lunar hollows are clues to the shapes of ice crystal.
We are still learning to recognize new kinds of patterns. Only within the last 30 years has humanity become explicitly aware of the two types of pattern now known as fractals and chaos. So what is fractals? Fractals are geometric shapes that repeat their structures on ever finer scales. Example, snowflakes and the branches of trees. So what is chaos? Chaos is a kind of apparent randomness whose origins are entirely deterministic. For example, cloud pattern and the current of the ocean. For example, the phases of the moon make a complete cycle from new moon to full moon, and back again every 28 days. A very curious pattern indeed occurs in the petals of flowers. In nearly all flowers, the number of petals is one of the numbers that occur in the strange sequence 3, 5, 8, 13, 21, 34, 55, and 89. There is a definite pattern to those numbers, but one that takes a little digging out. Each number is obtained by adding the previous two numbers together. For example, 3 plus 5 is equals to 8, 5 plus 8 is equals to 13, 8 plus 13 is equals to 21, and so on.
Numerology is the easiest and consequently the most dangerous method for finding patterns. It is easy because anybody can do it and dangerous for the same reason. The difficulty lies in distinguishing significant numbers, patterns from accidental ones.
He also discovered a very strange pattern related to orbital period of a planet, the time it takes to go once around the Sun to its distance from the Sun.
The main shapes that appealed to mathematicians were very simple ones. For example, they would be the triangles, the squares, the pentagons, hexagons, circles, ellipses, spirals, cubes, spheres, cones, and so on. All of these shapes can be found in nature, although some are far more in common or more evident than in others. For example, the rainbow is a collection of circles, one for each color. We don't normally see an entire circle, just the half or the arc of it. The rainbow seen from the sky can be complete circles. You also see circles in the ripples on the pond, in the human eye, and on the butterfly's wings.
Nature endless lot of stripes and spots extends into the animal kingdom with tigers and leopards, zebras and giraffes. The shapes and patterns of animals and plants are a happy hunting ground for the mathematically minded.
In addition to patterns of form, there are patterns of movement. In the human walk, the feet strikes to the ground in a regular rhythm. Left, right, left, right, left, right. When a four-legged creature, a horse, takes walk, there is a more complex but equally rhythmic pattern. Finally, there is another category of natural pattern. One that has captured human imagination only very recently but dramatically. This compromises patterns that we have only just learned to recognize patterns that exist where we thought everything was random and formless. For instance, think about the shape of a cloud. It is true that meteorologists classify clouds into several different morphological groups: cirrus, stratus, cumulus, and so on. But these are very general types of form, not recognizable geometrical shapes of a conventional mathematical. This scale independence of the shape of a cloud has been verified experimentally for cloud patches, whose sizes vary by a factor of 1,000.
However, you can play it with many of nature shapes, including mountains, river networks, trees, and very possibly the way that matter is distributed throughout the entire universe. In the term made famous by the mathematician Benoit Mandelbrot, they are all fractals.
Thanks to the development of new mathematical theories, these more elusive of nature's pattern are beginning to reveal their secrets. Already, we are seeing a practical impact as well as an intellectual one. Our newfound understanding of nature's secrets, regularities is being used to steer artificial satellites to new destinations with far less fuel than anybody had thought possible, to help avoid wear on the wheels of locomotive and other rolling stocks, to improve the effectiveness of parts pacemaker, to manage forests and fissures, even to make more efficient dishwashers. But most important of all, it is giving us a deeper vision of the universe in which we live and our own place in it.